I can use nets to help me find surface area of a three-dimensional shape. This is the most confusing diagram I think you will see all day when I'm going to try to explain what it's doing. What it's done is it's taken a net of a rectangular prism and it's unfolded it. I guess that's what a net is. So it's taken a net and then it's saying here's what it looked like before. And then it breaks it up by each side. So if you notice this gray area, and I'm not sure how well you can see this on camera, I'm going to actually outline these in all different colors so you can kind of see what's going on. So this gray area is, they're saying, the back of the prism. And then it took this side over here, and it's saying, oh, well then this green one, if we folded it up, it's actually this side of the prism. And then it takes this checkered kind of area over here. We need a lot more colors, I think. And it takes this one and says, oh, well that's actually this side over here. And then we have this one in blue. And that one in blue, where did they put it? Oh, right here on the bottom. And then this one right here is going to be in red. The kind of wavy pattern they put up here in the front. And then finally, other blue on the top. So we know that a right rectangular prism actually has this many sides. If we unfolded it, it would have 6 sides. And we've covered all of them. We've got the left side, the right side, the bottom, the front, the top, and then the back over here. It's really interesting because some of you, when you saw this before I drew the arrow around that, you saw that as the front. So different people kind of perceive them differently, which is the interesting thing about 3D. But if I want to find the surface area, that's the area that covers all of my surfaces. Probably should have defined that. I think maybe I do on the next slide. So it's the area that covers all my surfaces. So if I had a cube and I wanted to wrap it in wrapping paper, surface area is what I would need to find out because I'm going to have to find out how much area I have that I have to cover. So I would have to find the area of each of these individually. And I don't know that I'm going to do it on this slide because I think I can figure it out on the back, but let me go ahead and go through quickly and sort of talk about it. So this is a 2 centimeter by 4 centimeter rectangle. So the area of this one is 8 square centimeters. Now notice we're talking in 2 dimensions now, not 3 like we were with volume. So this is actually going to be squared. Now these ones are a 2 by 2, so it's going to be a 4 centimeter squared area, and this one matches it because it's opposite. And then this is a 2 by 4, so it's 8. This one is 8. And this one is 8. If I want to know the total surface area, so how many square centimeters of wrapping paper I would need for this box, I'm just going to add up all the surfaces. So I have 8 times 4, which is 32. And then I've got 4 more, that's 36, and 4 more, so that's 40 square centimeters. That's how much wrapping paper it would take if I wanted to go ahead and cover this shape. I've got a lot of erasing to do because I used a whole bunch of colors. So here it is, the definition of surface area, make sure you write it down. Surface area is the sum of the area of all of the faces. So we talked about the faces being the flat edge of a shape. So it's pretty easy actually if we have a net set up this way to find its surface area, especially on this one because I can count up all of the boxes. But I'm going to go ahead and put some numbers in here anyway. This is 2 centimeters this way, or 2 units, and 1 unit that way. So this little rectangle here is going to be a 2 by 1, so this is 2. This one is going to match it. It's going to be the same thing. by 1, so it's 2. Now this one up here, this time is going to be a 1 by 2, but it's not going to matter, it's still going to be just 2. And this one is going to be a 1 by 2, still just 2. Now I have these guys left. You can tell just by looking at it that it's going to be 4 units, but if I wanted to know for sure, it's 2 this way, and it's 2 this way, so it's 4. And this one is 2 this way, 2 this way, it's 4. If I want to know my surface area, just add it all up. 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 4 more is 16. So this is 16 square units. If I want to check, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So surface area is really not too bad if you have the net and it's already given it to you. All you have to do is find the area of its surfaces. Although, as you'll see on the next slide, it can be a little bit more confusing. It's still, I don't think, going to be too bad. First of all, what kind of figure do you think this will fold up to be? One thing you need to determine is what kind of base does it have. So you notice the base is going to be the only thing that's different on this. So it's got a rectangular base, or a square base in this case, but it's a rectangle. Because a square is just a special type of rectangle. But you notice it doesn't have another parallel base, so it can't be a prism, because prisms have to have 2 parallel bases, and I only have 1 base on this one. So if you think about this being the base, and you take these corners, and you fold them up, they're going to meet at a point. So what I have is a rectangular pyramid. I know it's a pyramid because it meets at a point. I know it's a rectangular pyramid because its base is a rectangle, or in this case a square. So I'm going to go ahead and find surface area. This is I'm going to label the sides that I know. This is a 3 by 3. Remember when we find triangles, we have to find the height as a right angle because you can't measure somebody who's laying down, so they have to be standing straight up. So my base is 3 of this triangle, but my height is going to be from the base to the tallest point. So I'm going to make a straight line. And you'll notice that in this case, that's 1, 2 units. So it's going to be 2 units tall. So I'm going to go ahead and find the surface area. My rectangle is not going to be hard because it's a 3 by 3. So 3 times 3 is just going to be 9. These ones are a little more complicated because those triangles, I'd have to find the area of a triangle. Here, I'll put area of triangle is 1/2 the base times the height. So my base is equal to 3. And my height is equal to 2. And I can do half the base times the height. I could actually, since I'm multiplying them, I could actually switch them and do half the height times the base. It's going to work out the same. But I'm going to go ahead and use the other formula instead on this one. And I'm going to say, I could also say it's base times height divided by 2. If I use that, I have 3 times 2, and I'm going to divide it by 2. And I can actually see right here, I'm going to end up with a 2 divided by 2. That's just going to go away. And my area is going to be 3 units squared. If you actually solve this out because you didn't see this trick right here, then you have 3 times 2, which is 6, and 6 divided by 2 is going to be 3. So each of these are all exactly the same, so they're all going to be 3 units. So my surface area is 9 plus 3 plus 3 plus 3 plus 3. So I'm just going to go 3 times 4, which is 12, and add 9 more on, and I'm going to have 21 square units. Tomorrow you're going to have to be able to do that on your own, so make sure that you understand. If not, watch the video again and see what happened there. I'm hoping you can see those blue lines pretty well on the camera. And that's it for this video. So hopefully you feel like you can use nets to help you find the surface area of a 3-dimensional shape.